Welcome back. Knew you couldn't stay away. So we've talked about the power rule, we've talked about the product rule. Now we're going to talk about the quotient rule. What's the quotient rule? Well, remember, quotient means fraction. So we're going to look at the derivative of fractions. And what's going to be special about these fractions? We're going to have variables in both the numerator and the denominator. So let's go ahead and get after it. So our rule here, if we're given f of x as being two functions being divided by each other, g of x divided by h of x, the rule is h of x times g prime of x minus g of x times h prime of x, all divided by h of x squared. Good gracious, how do we remember this one? Well, I got to give some props to my calculus teacher. I don't know where he got it from, but he gave us this little mnemonic to remember it. So he says, low de high, less high de low. Draw a line, denominator squared we go. So low de high, less high de low. Draw a line, denominator squared we go. No laughing, music majors. I know I'm not the most musically inclined, but it kind of rhymes a little bit. So what does this mean? Our low means the bottom in this case. So we have the bottom, our h of x. D high. D is going to stand for derivative of the high. So we have the denominator times the derivative of the numerator. Less means minus. High d low. So our top, our numerator, times the derivative of the denominator. Now we drew the line, we drew the fraction line, the quotient line, and then we took the denominator and we squared that denominator. And that's going to be our quotient rule. So you can remember it. You can remember the symbols of it, the rule of it, or you can remember the little mnemonic. I kind of like the mnemonic. I kind of sing it in my head as I do quotient rules. I still do it after so many years of first learning the quotient rule. So let's look at example 1 and let's find the first derivative. So I'm going to take my low, always start low, and then I go d high. So our denominator times the derivative of the numerator, minus less high is x plus 3, derivative of x minus 5 gives us 1, over the denominator squared we go. So we drew the line, denominator squared we go. Alright, now we can go ahead and clean this up. Please remember your rules for complex rationals or just rational expressions together. We cannot cancel those x minus 5s. We have a binomial up here on top. So we're going to clean this up. We have x minus 5. We're going to distribute that negative through, so we get a negative 5 minus 3. Hopefully these kind of remind us of problems that we saw in Algebra 2 and in pre-calculus, simplifying rationals. They are very important to us, and I give them to you back then because of these kinds of problems. Remember those ones? Why do we have the ones on there? We don't need them. Well, yeah, they don't mean a whole lot until you get into a calculus problem, then you see them here. So go and clean that up. We get a negative 8 over an x minus 5 squared. And that's our first derivative. And we're done. Not a whole lot left that we're going to do with that. Here in example 2, find the first derivative. So my low, I'm going to rewrite the tangent of x, derivative of x squared, which is 2x. From that, we're going to subtract the high, x squared, derivative tangent of x. Hopefully remember that's going to be our secant squared of x. Remember our trig derivatives. And then we're going to draw our line, denominator squared we go. So tangent squared of x. Again, we could clean this up. What do you see? What could we do? I see an x in both of these quantities on the top. Remember, we cannot cancel the tangents of x. That's a big no-no. So I can pull an x out. I can put my 2 in the front. So multiple choice kind of question. I would probably see it as the x times the quantity of 2 tangents of x minus x secant squareds of x all over the tangent squared of x. Again, probably going to see it that way. We could break this up into different things, but again, probably not going to see that. If anybody wants to see that, we could play around with it later on, if need be. Here in example 3, it's going to be a little nastier, a little uglier, because we have a radical in it, but hopefully it's not going to scare us away. So remember, the square root of x is simply x to the 1/2. So our first derivative is going to be x plus 3, our denominator. Derivative of the numerator, 1/2 x to the negative 1/2. From that, we're going to subtract x to the 1/2 times derivative of the denominator, which is 1, divided by x plus 3 squared. Again, if it's multiple choice, it's probably not going to be in this form. Extended response, we would probably leave it. So how are we going to see this in a multiple choice? We'll probably see no negative exponents. So we'll probably have to take this and make it positive. We cannot just simply take it to the denominator of the entire fraction because it's being subtracted from some other stuff. So I'm going to go ahead and make this a complex rational. X plus 3 over 2x to the 1/2. Remember, the 2 is already in our denominator, making a negative exponent positive by taking it to our denominator. And that's minus an x to the 1/2 over x plus 3 squared. Make this a fraction over 1. Common denominator is going to be 2x to the 1/2. So we get x plus 3 minus, we multiply 2x to the 1/2 to our x to the 1/2, we get a minus 2x. And that's over our x plus 3 squared. We make this a complex rational, is putting it over 1. And go ahead and clean it up. So that's going to give us x minus 2x gives us negative x plus 3. Our denominator, this x plus 3, remember that flips and multiplies. So we're going to have 1 over x plus 3 squared. So multiply those together, we get a 2x to the 1/2 times an x plus 3 squared. And that's going to be our nice, clean, multiple choice answer that we're going to be looking for on a test or a quiz. All right, example 4, more of a typical kind of question that's going to be asked of us. Can we find the equation of the tangent line given f of x equals x squared over cosine of x, and x is 3 pi over 4. So, again, we're going to need the slope, and we need a point. And we know one piece of information. We know the x value. Can we find the y value? Can we find the slope? So we can go ahead and find that y value by finding f of 3 pi over 4. So we have 3 pi over 4 squared over the cosine of 3 pi over 4. If we clean that up, we get 9 pi squared over 16 divided by the cosine of 3 pi over 4. Cosine of 3 pi over 4 is going to be the negative of the square root of 2 over 2. Hopefully remember, go back to the unit circle. We're looking here. Nice 45-degree angle for our reference angle. That gives us a negative radical 2 over 2, radical 2 over 2. Looking for the cosine of that, the x value gives us negative radical 2 over 2. We could clean that up just a little bit if you want. Let's see, we get 9 pi squared over 16 times a negative 2 over radical 2. When we flip and multiply it, canceling that out, the 16 and the 2, it gives us an 8 and a negative 1 up there. So we get the y value, the y coordinate is negative 9 pi squared over radical 2. Again, you could rationalize that if you want. We don't need to. We have the y values, so that's all we really are interested in. Can we find the slope as well? So we have the first derivative. Our first derivative is going to be the cosine of x times 2x. From that, we're going to subtract x squared times the derivative of cosine of x, which is negative sine of x, all over the cosine squared of x. This is going to be kind of an ugly, nasty problem, isn't it? So go ahead and plug in your 3 pi over 2. So we have the cosine of 3 pi over 2, or sorry, 3 pi over 4. Again, we have negative radical 2 over 2 times 2 x's. So 2 times 3 pi over 4 is going to be 3 pi over 2. From that, we're going to subtract that square, that x value squared, which again was 9 pi squared over 16. We found that earlier. And then the negative of the sine of x. So the sine of 3 pi over 4 is radical 2 over 2. We're taking the negative of that. So we get a negative radical 2 over 2. And then cosine squared. So again, we're taking negative radical 2 over 2 times negative radical 2 over 2. That sounds cumbersome, doesn't it? Well, we got radical 2 times radical 2 is radical 4, or 2. Negative times a negative is positive. So we get a positive 2 in the numerator over 4, or we get a 1/2. So that gives us 1/2 in our denominator. Very ugly, ugly, ugly slope there, isn't it? Let's see, we can go ahead and clean that up. Running out of some room here, though. So we get negative 3, radical 2, and we get a pi in there, and that's over 4. We have a negative times a negative gives us a positive. Here we have 9 pi squared, radical 2's over 32, and that's all over 1/2. Oh goodness, let me see if I can find a piece of paper here to finish this thing up. So pushing the paper up a little bit there. Let's see, common denominator is going to be 32, so we need an 8 there, so we get negative 24 pi radical 2 plus 9 pi squared radical 2. That's all over 32, which is all divided by 1/2. So if I flip and multiply, let's see, I'll look at 32, and then we're going to multiply that by 2 over 1, so that gives us a 16. So our slope, good gracious, our slope there, m, is going to be a negative 24 pi radical 2 plus 9 pi squared radical 2 over 16. Obviously, I did not vet this problem before I started the problem. Good gracious. So our equation, we have y minus the y1, so y plus 9 pi squared over radical 2 is going to equal the slope, negative 24 pi radical 2 plus 9 pi squared radical 2 over 16 times x minus 3 pi over 4. Good heavens to Betsy's. I would leave it just like that. I would definitely not try to manipulate that at all. I may have even, rewritten all of this as my slope and said, the heck with it, being an extended response question. Definitely a legal thing to do there, extended response, because we don't need to do any of the basic mathematics there. And last but not least, here we have another one of those AP kind of questions where it's giving us a function based off of other functions. Can we find the value of a derivative? So here we have 2 times f of x plus f of x divided by g of x. Find h prime of 1. So we find h prime of x to start. H prime of x is going to be, well, here we have 2, which is a constant, times a function. So the derivative is going to be 2 times the derivative of that function. And then we have f of x divided by g of x. So that tests our quotient rule. So we have g of x times f prime of x minus f of x times g prime of x divided by g of x squared. And we're going to find h prime of 1. So h prime of 1 is going to be 2 f primes of 1. So that we're going to add a g of 1, f prime of 1, minus f of 1, g prime of 1. And that's divided by, just that part's divided by g of 1 squared. Good goodness. So again, we read the chart, just like we did when we did one like this with the product rule. So we have 2, f prime of 1, f prime of, we go to 1, f prime is 5, g of 1 is negative 2, we're multiplied by f prime of 1 again, which is 5 we just had, f of 1 is 3, g prime of 1, that's kind of nice, that's 1. Oh, we stop it there. Knew I was going to make that mistake. And then over g of 1 is negative 2 squared. So we have 10. To that we're going to add a negative 10 minus 3 gives us negative 13 over 4. Again, we could leave it like that if we want. You could go ahead and multiple choice. It'll probably go ahead and give you a nice common denominator. We have what? 40/4. 40 minus 13 gives us 27/4. And that's going to give us a nice example of using the quotient rule, more of a theoretical type of question instead of giving you the functions to find it. Good luck!